Welcome back, guys, and we continue with tropical cyclones in question 1.3.6. Now the next question, evaluate why the impact of tropical cyclone is more severe in a country like Mozambique than in developed countries. Now let's just quickly distinguish between the two. Mozambique is a developing country. Developed countries like America or Britain, England. Now the reason why it's more severe is because when we look at Mozambique, first of all, most of the people over there live in rural areas. So when a tropical cyclone will hit Mozambique, it will cause more damage to the infrastructure, and it will be more severe, and it will be more life-threatening. And the reasons for that is because Mozambique is a developing country, most of the people stay in rural areas, so communication to the rural community is going to be extremely difficult. Then another reason for it is because if you look at the infrastructure is not as well built as in developed countries. Most of their houses are huts or made out of zinc or wood. So the destruction of property is going to be greater than in developed countries. So we can just mention over here weakened infrastructure that do not use proper material for their building materials. Another reason why is because they don't have proper evacuation and warning systems in place. For instance, America knew, for instance, during Hurricane Harvey, that a tropical cyclone, a hurricane, is on its way. So they can take the precautionary measures to warn the people. But unfortunately, Mozambique, because it's a developing country, they don't have this type of technology to warn their people well in time. And another reason why we experience a higher death rate in a country like Mozambique is because of poor medical facilities. And if you look at developed countries and developing countries, there's many more doctors and hospitals in developed countries, such as in countries like Mozambique. So they will struggle with the high influence of people that's getting injured or people who may have lost their lives. Another reason that we can add over here, many people do not know what to do when a tropical cyclone hit. For instance, when Hurricane Harvey took place in America, most of the people evacuated. For instance, Houston, a massive city. But where do these people go? They don't have the knowledge to do how to evacuate or how to prepare themselves for the tropical cyclone. Now, very importantly that you need to pay attention over here. Each question in your question paper will consist of a similar question to the one in 1.3.6. And if you look at the mark allocation, 4 times 2 equals 8. Now, most of the time, almost every time, not most of the time, this question needs to be answered in paragraph formation. I've written it down in bullet formation, but please, when you do answer this question paper, do write it in paragraph formation and not in point or bullet formation. If we continue with our questions, let's quickly have a look. And this shows us an urban heat island. And figure 1.4 represents microclimate. Now, as you can see, basically what we have over here, we have a graph. On the vertical axis, it represents temperature. The horizontal axis, the urban profile. Urban profile, as you can see right in the middle, is the CBD, light industries next to it, suburban areas, and eventually the rural urban fringe. Now let's quickly have a look at the questions that follows regarding this graph that represents temperature on the one side, on the vertical axis, and the urban profile on the horizontal axis. Which areas in the city experience the highest and lowest temperature respectively? Now this is a graph, and all the answers and information that we can get is from the graph. Now as you can see, which areas experience the highest temperatures? There's 33 degrees, so the CBD experienced the highest areas. Which areas experience the lowest areas? The rural urban fringe. Transition zone from the urban areas to the rural areas. So let's quickly go and look at our answers. Write down our answers over there. CBD is the highest. And the rural urban fringe is the lowest. Okay, our next question is define the term urban heat island. Now as you can see in the diagram, urban heat island, this area over here is known as urban areas because there's secondary and tertiary activities taking place over here. Definition for urban heat island is when an urban area experiences warmer temperatures than the surrounding rural areas. And as you can see, quickly look at the temperature, it increases as soon as we move to the urban areas, and it decreases once we move to the rural areas. Okay, define the term urban heat island, and where urban areas where higher temperatures are surrounded by lower temperatures of the rural area. Okay. State one difference between an urban heat island and a pollution dome. That's two terms that you need to get yourself familiar with. Now, pollution domes, when do we experience them? We usually experience them during winter. Now, urban heat islands we experience during daytime, and pollution domes usually during night times. Now, if you look at the graph, if you look at the temperature, it's been experienced during daytime because look at the temperature up to 33 degrees Celsius. But the pollution dome is more dominant during nighttime because what happens is sinks and it traps the pollution over the urban areas. So what can we say? The urban heat islands are more prominent during day, and the pollution domes are more prominent during night because of subsidence during nighttime. And the heat islands, it's got a greater vertical dimension, it's higher up during the day, and the pollution dome is closer to the surface during the night. Now give one reason why a pollution dome forms, that's the next question, is because the pollution are being trapped by the inversion. That's the reason, for instance, over the areas, because the pollution is trapped by a inversion. Okay, and that usually happens during nighttime when the air cools through terrestrial radiation, but because of the pollution, what happens? The warm air can't escape, so it's trapped between the pollution and the surface. Now discuss two factors evident in figure 1.4 that cause cities to record higher temperatures than the surrounding rural areas. Now I want to go back to this diagram over here. Why do city areas such as the CBD experience warmer temperatures than the surrounding rural areas? Now very simple. Great task. If you look at CBDs, for example, city areas, it lacks plants, it lacks trees, it lacks open water surfaces. Most of the buildings are built out of what? Concrete. And what does it do? It absorbs heat. If you look at the rural areas, most of it is covered with vegetation, it's open water surfaces, and there's less human activity. So most of the heat that's being generated in CBDs is artificial, it's fake. If you look at the amount of cars, more cars means more pollution, carbon dioxide, more air cans being used, so that increases the temperature in CBD areas. The same with the light industries taking place over there, generating more heat with their activities of production. So what can we write over here? If we look at the question over there, discuss two factors evident in figure 1.4 that can cause cities to record higher temperatures than the surrounding rural areas. More artificial surfaces that absorbs heat. Artificial surfaces, it absorbs more heat. Artificial, let me just quickly correct my spelling over here before I'm going to get in trouble with the English teachers. There you go. Absorbs more heat and it lacks vegetation. Now, the next question for 4 marks, if you were an urban planner, describe how would you sustainably decrease the impact of urban heat islands. Now, what can we do? What can we do to reduce these high temperatures over the urban areas? Now, we can come up with quite a lot of ways. Now, first of all, instead of using our own transport, what can we do? Use public transport. Now, think about all the emissions being created by one car. Now, let's say 20 people using their own cars, the amount of emissions has been created by 20 to 50 cars, whereas people might use a bus. It will reduce the amount of emissions and it will reduce the amount of pollution and heat. Another reason what we can do, we can be more green. Instead of using cars to go to work, use bicycles. It will benefit our health as well. That's another example that can be used. And then buildings, instead of, you can use material that reflect the heat instead of absorbing the heat. And what we can do as well, create more green belts. Green belts, for instance, is parks where there's vegetation, because the parks has a cooling effect on the CBD. So what I've mentioned over here so far, we can use, create more green belts, we can use less materials that absorbs heat. We can use a greener form of transport. Okay. And less material absorbs heat over there. And then last but not least, what else can we do? Invest in rooftop gardens. Once again, adding some vegetation to these urban areas. And it will definitely have a cooling effect on our urban areas. And once again, countries also invested in government-made plans regarding congestion, only allow a certain number of vehicles in the CBD because it creates more congestion and can create more pollution and heat. Now, if you look at figure 1.5, is a sketch of a river system. Now, when we look at the river system, we know if you look at the longitudinal profile, We know a river system consists of a source and the mouth, where the water originates from and where it basically flows into the ocean. Now, this river system, as you can see over here, if I can draw a side profile of this river system, this is a synoptic view, an overview of this river system. As you can see, there's the source and there's the mouth. Now, when we look at this river system, it's the main river flowing, and as you can see, it starts to meander over here, eventually where it flows into the ocean. The other rivers joining this river, what do we know them as? These rivers are known as tributaries. Okay, now this whole river system, what is known as a what? A drainage basin. Okay, now what separates one drainage basin from another drainage basin? And this is being indicated over here, this area over here is known as the watershed. And what separates one tributary from another tributary? Just fill in over here, this area over there. Just use a different color. Just use that color over there. That is known as a interfluve. After the break, we're quickly going to continue with the next question regarding drainage basins. Stay tuned.